Okay, so I hope you can see the slides. Please reply yes if you can. Okay, let us start. So today we will be continuing our problem solving session on natural language processing, which is a course conducted by NPTEL, and the instructor is Professor Pawan Goel. This course is conducted by Institute of Indian Institute of Technology Kharagpur, and I am Punyajoy Saha, which is the teaching assistant for this problem solving session. Now, in this week, we will be looking at. So, previous week was mostly about computational or semantics. This week, we are looking at lexical semantics. In brief, lexical semantic is concerned with the systematic meaning of related connections among lexical items. And we will check how these are getting applied in the questions. So, for reference, I have given a list of different um, types of connections. So these are homonymy, polysemy, etc. We will refer to these connections when we are looking at the questions. So let us go to the question first. So these are the 6 sentences. Now, um, and you have to find the lexical relation between. Yeah, you have to find the lexical relation between 1 and 2, 3 and 4, and 5 and 6. So first, so 1 and 2. So what is the lexical relationship between them? So let us. The statutes are cast in clay molds, and Indian caste system is an example of social stratification. We have to find the lexical relation between caste and caste. Can anyone tell what is the lexical relation between these two? Let us go back to the reference. So yeah. So do you see any of them which links caste and caste? That is CASTE and CAST. Out of these different references, can you see which one will actually um, which actually define the lexical relation between these two words? No, not exactly. That holds between words that have the same form with unrelated meanings. So the words should be same here. Here the words is caste, that is CASTE, and caste, that is CAST. That is not, yeah. Homophony is the correct answer. Okay, let's go to the second one. So so third and fourth. My dog would always bark at strangers, and trees bark as medicinal value. So what is the relation between these two? Let's go back to the definitions again. So which one of these uh, qualifies as a lexical relation between bark and bark? Anyone? Polysemy. Okay. No, polysemy is multiple related meanings within a single lexeme. So that is a single word carrying multiple related meanings. These are two different words. So polysemy is when the word is used in the same context or same meaning, but they're slightly changed in their way of usage. I will come to it later. So the next one. So, but what about this bark and bark? These are two separate words. This does not have any connection. So this will be homonym. That is that holds between words that have same form, but the meanings are completely unrelated. And uh, and then okay. So the last one is the newspaper was delivered early today, and newspaper recruited a news investigative journalist. Here it is polysemy because here the newspaper is a single newspaper, and here it is a institution, newspaper institution or like newspaper institution. So here it is polysemy. So the same word or the same word is being used for different purposes. So the correct option will be this. Okay. Next is although the so consider the sentence. Although the buttons did not look good on the shirt, the dress fit well. Which of the following are true? Dress subsumes button. Shirt is a hyponym of button. Dress is a hypernym of shirt, and button is a meronym of shirt. So let us go back to the definition. So subsumes again means that so hypernym basically. So what is hypernym? Yeah. So one sense is a hypernym of another. The first sense is more specific. Unit subclass. So converse is hypernym. So in hypernym, the first word will be more broad than the second word, like, and the second word should be a subclass of the other. And meronym is transitive relation between senses. So this basically means a part of the particular word. So for example, if I say a computer, then it can have parts like mouse or keyboard. So that will be like keyboard is a meronym of the computer. Yeah, so out of this, which one is true? Which of the following is true? So before that, is there any doubt in the first question? Three and four. Why three? Yeah, why three and four? Like I am asking the reason. So what is the justification? Short is specific. Okay, yeah. And yeah, button is a part of short. So yes. So let us go. Yeah. So these are the correct options. Yeah. So then we are given a hypothetical wordnet noun taxonomy with the information content. So each of these brackets is the information content that we will use later in the questions. So let us see the question first. Now the question is, what is the Resnick similarity between car and motor vehicle? Yeah, so what we do in Resnick similarity, we first find the lowest uh, lowest common subsumer. So we have to find the a common node which subsumes both C1 and C2. So that is meaning of LCS. And IC is the information content, that information we already have. So let us look at the car and motor vehicle. So here the common node will be so we go from car to motor vehicle. So we reach motor vehicle, and this is also motor vehicle. So this is the common node that subsumes both car and motor vehicle. And then we calculate the Resnick similarity is in the IC of motor vehicle, that is 9.53. Here is the given definition. So that is basically the case. Then we have to find the length similarity between cycle and article. So let us try to do this. So length similarity is 2 log p LCS by C1 comma C2 log p by log p C1 plus log p C2. And if I write in terms of IC, then it will just a minus added everywhere, which will cancel out. So basically the overall equation become 2 of IC LCS C1 comma C2 and IC C1 plus IC C2. Now let us try to see the graph. So we have to find the similarity between cycle and article. So what do we do? Yeah, so from cycle we have to find the common subsumer of cycle and article. So what will be the common subsumer or common word which is like is a hypernym of both article and cycle? What will be that? Can you tell? Vehicle. No. Cycle and article. Vehicle is here.
Artifact.
How to
Artifact.
find? Oh, artifact. Okay, okay. Yeah. Yeah, artifact is the character. So what is the basic logic here? So if you are not able to, if the graph is large or there is no like clear, usually the graphs are small here, but if it's somehow large, then what you have to do, traverse back from the given word. So cycle will go to wheeled by vehicle, and here also we can make one back option and just go till everywhere where you can reach the common node. So you can do this way that, so for example, if you reach artifact, whichever is in the more depth, you can traverse back that first and traverse it until it reaches some common node. Yeah, so this is the technique shown. So we will get artifact here. So that is the information content 3.53. So what will be the solution here? Minus 2 into, or minus 2 you can leave it, 2 into IC of LCS, so IC of artifact, right? And then we have IC of cycle and plus IC of article. Okay. So that is the formula. So now calculate and tell me what will be the final value of this. So 2 multiplied by IC of artifact by IC of cycle plus IC of article. So what will be the final value using this graph? Yeah, can you tell what will be the final values of this value length similarity? Just you have to put in the formula and then calculate using a calculator or something. Yeah, what will be the value, final value for this? Are you doing it?
Point 452.
Okay. Yeah, please write down in the chat and I will check together. Anyone else? Minus 0.44. Okay. Anyone else? Okay. Yeah, close enough. Others? Yeah, minus we have removed, so minus is not. Others? Uh, Other than Satish and Lakshana, others, if you have any doubt in the process, you can also ask. Okay, so let us try to solve it. So what we do, we calculate this. Uh, so our one of Lakshana or Satish, can you please tell what are the values? So 2 into,
3.53
okay, and
divided by 5.26
26,
plus 10.35.
okay. This comes out to be, yeah, 0.45. The minus is not required because we are using minus on both denominator and numerator. So that is the basic idea. So whenever you are facing these questions, you have to know the two things. One is what is the graph or this coordinate graph, and what is the formula for that particular similarity calculation. Now we're interested in measuring the Ryan-Conrad distance between object and cutlet, and the formula I have given here. So it's the same as here, and here we have. So first we have to find out the LCS between object and cutlet. Okay, let us see. So what is the, now I think you are well versed how to find it. So what is the LCS of object and cutlery? No, we do not need the logarithm here because we are directly given the IC. If we are given the probabilities, then we have to take the log. So none of the questions here will be having the log. So what is the hypernym of both object and cutlery? Like a common hypernym.
Object itself.
Yeah, the object itself. Right. So this becomes, yeah, so this becomes 1 by IC of object plus IC of cutlery plus 2 IC of again object. Okay, so this is the formula. Sorry, minus. Yeah, so let us calculate using this graph. Yeah, so what will be the final solution? So it is IC of cutlery plus IC of object minus 2 into object IC of object. So one and everything is below the everything is denominator and numerator is 1. So calculate the value then using this graph. So we already know the ICs. Yeah. So tell what will the value? Let's write the formula. Yeah, Lakshana. Okay. Anyone else from the ones who have not replied? So if you are understanding, please try to solve the question because this may come in the exam. These are very easy questions. Like easier than the ones we had already, like in week 6 or 7. Oh, sorry, week 5 and 6. Yeah, using the formula I have given, try to solve this question. 0.126, okay. The formula is given in the chat and you can use that to solve. Okay, we have two different answers. Anyone else? Okay, let's forward. Forward. Yeah, so this is basically the flow, how we find the object. And then we do this 1 by 9.72 plus 2.79 minus 2 into 2.7. That is 1 by 6.93. So basically we are doing my 9.72 minus 2.7. That gives around 0.144. So what was the error for you, Khyati? Yes. So yeah.
Actually, I have divided by 1 plus IC of C1.
Okay, okay.
That's why.
Sorry about
Mm.
that. That should be all in brackets. Yep. So that is so. So I understood the questions, right? So this will be the common strategies that this question will be asked. So these are very like high scoring questions if they come, and you can easily score a lot if you know the formulas and know how to find the common ancestor, common sub element which subsumes both the words. Okay, for the next one, any doubts?
Sir, can you please share these PPTs with us?
Yeah, these are already shared. I guess you in your NPTEL course page, you will see such like there is a problem session link. In
Okay.
that, it will be linked to a Excel sheet. Just ask one of your fellow like learners. They will show how.
Okay. Okay. Thank you.
My PPTs as well as PPTs of other other sessions are also added. Okay, for the next question, we will basically.
You can open this link. I have given this for that Excel sheet.
Oh, okay. Thanks for that. Yeah, for the next questions we will use the so now in till this question we are using like a hypothetical word net that is given to us. But actually this word net is pretty large. So and that is stored in a NLTK based corpus reader. And this you can go to this link. Yeah, this basically shows how we can use this NLTK corpus, this word net. So what you can do? So let us try it. Uh, running it. Yeah. So can you see the notebook, like the code part?
Sir, can you please zoom it?
Yeah. Is it fine now?
Yes, yes.
Okay. Now, so when you are, I will share this link as well. So when you are first installing this NLTK, you have to install WordNet as well as this one, OMW, to run all the codes that are given here. Okay. So now let us try the first one. So basically, you have to load the nltk.corpus import WordNet. So if I just do this, it will basically it will download all these things and then we can load it. And for simplicity, we will try using this like WordNet as WN, but you can avoid it here. Now let us try one. So first we will try to find the synonyms of the word dog. Yeah, so these are the synonyms of the dog. So you can see that dog is also one part of it. And there are different uses of this. Let's say you want to find the verb part or sense. Okay, I think let us go to the questions then come back. Yeah, so the first question is question number 6. So they have to find the lowest common hypernym between the first sense of man and second sense of whale. And what is its maximum depth from the root? Okay, so now what you have to do? So first we will find out the first sense of the man. So that is man, n, that is now, and 0, 1. So that is the first sense. So this way there are many sense of the that we already said. Like there is a lot of sense of the word man. So if I just say man, oh sorry, yeah. Yeah. So these are the different sense of the word man. Okay. Now what they are saying, we have to use the first sense. So that is this one. That's why we have to use this one. And the second word is whale.
Excuse me, sir. Are
Yes.
you showing the slides only?
Oh, sorry. I think it is better if I share the entire screen. Yeah. So can you see the screen now?
Yes, sir.
Yeah. So the first sense of man is this. So that we have to use. We have to use the second sense of whale. This is the second sense of whale. That is this one. Next, what we have to find out, let us see the question. We have to find the lowest common hypernym between the first sense of man and second sense of whale. So we are doing something like this: print man dot lowest hypernym and whale. So this will find the lowest hypernym. So this basically acts as a function that we used in the graph. So in the graph, if you notice, we are actually doing the same thing using this thing, like using this arrows. So we are trying to find the hypernym. But this is implemented as a function and that we can directly use. So if I say this, so this will come as organism, which is okay, intuitive enough. And now you have to find the maximum depth from the root. So maximum depth from the root will be which one has the. So if I say, for example, here, if I want to find the maximum depth between motor vehicle and let's say bicycle from the root. So which will be at the maximum depth? The bicycle, because it will have to travel more of this part. So that's what is meant by maximum depth. So here we are trying to see the maximum depth between man and whale, which one has the maximum, and what is the maximum value? That is 5. So this question's answer will be organism n.01 and 5. So here it can be you have to be very specific about the sense of that word. So you have to add all this noun and 01 as well, which specifies the sense, which sense ID it is. If you just say organism, it will be a wrong interpretation. There is nothing like organism in the word. It always will be having a 3-part structure. Okay, next we want to find out the Chodro and use Palmer similarities with the first sense of the word form and institution. So let us again do this. So here we have to use the first sense. So form equal to WN insert. So if you do not know the first sense, this is one way to do it. Like you will get a list out of this. So if I print this. So earlier we have to check like which one is the first sense. Now we can directly use something like WN inserts form and 0 element. So that will be the first sense. Similarly, we can do this for institution. Yeah, so this is the first sense. Now we have to find the first is the Lichak-Chodro similarity. So these are all encoded in a sim function, and you have to just write the function and enter the second one. So similarly for the other one, and you find the solution for that. So this way we have a lot of similarities that we can write. So we can also write I think the Resnick similarity perhaps. Yeah, so this way you have to find out which one is what. I don't think this kind of questions will come in the exam, but this is a good practical to see. And this is the correct option. Yeah, then we have consider the sentences. Heat the solution to 75 degrees Celsius, and she provided a brilliant solution to the long-standing problem. What are the definitions corresponding to the senses of the word solution as per the Lex algorithm when using senses from WordNet? And there are 4 options. So how do we solve this? So again, let us go back here. So what we are doing, we are trying to find the name as well as the definition of the particular word. So we will just use the wn.synset solutions. So this is similar to what we were doing earlier. Yeah. And for each of the synset again, the senses, we will try to see their name as well as the definition, and we will see something like this. So N01 is this definition, N02 is this definition, this way. And if you match this with the original text, so let us see a method for solving a problem. So is there a particular thing? Yeah, so a method for solving a problem. So there is the third sense. A statement that proves solves a problem or explains how to solve the problem. Let us see. A statement that solves a problem or explains how to solve the problem. This is also there. A homogeneous mixture of two or more substances. Yeah, so heat the solution. So solution is the first, so the second one matches with this part, like the Sri provided brilliant solution. That is a statement that solves a problem, and the some errors. Yeah, I think there is some error here. So it will be, yeah. So first one will be the set of a statement that solves a problem or explains how to solve the problem, and the second one will be a homogeneous mixture of two or more substances. So 2, 3, and 2 will be the correct option. Did you get my point? So what you have to basically do is replace the, try to see which of the definitions actually hold. So you will get all the senses from here, and then try to see in the sentence what are the definitions that hold. So instead of this, yeah. So this is the last question that we're going to do. Now let us look at the NLTK WordNet for a bit, because that is interesting. Yeah, so let us try with this one. So we are having this first sense of dog. Now what we can do is, so we want to know what are the hypernyms of dog. You see, canine, domestic animal, etc. And we can also check hyponyms. And there you go, like there are different species of dogs that are given. This way, do you want to check anything else? Let's say man, adult, male, okay. And what can be the hyponyms? Can anyone guess? What will be the hyponyms? Yeah, Adonis, bachelor, black man, boy, etc. There is a lot of it. And then what we can do? Yeah, this we have already studied. So let us say we want to find the antonyms of. Yeah, so there are no, so we can use this one. So you can see that man is the opposite of man is woman. So that is also common. Yeah, then we are basically doing the different types of path similarity. So that is in the question as well. So the LCS similarity is also there, W similarity is also there. And then we have the information content. So if you want, you can also see the information content of different words. Yeah, so we have the dog and race similarity. Right. So these are information content using different versions of the probability values. Yeah, so when you are running NLTK, you have to sometimes you have to download some of the libraries. Some of the they are not present defaultly. Yeah, so these are two different versions. And then let us try this one. Dog. So the IC part that we are using here is basically providing us with the values. So if you see the graph here, we are already provided with the values of the IC. So this brown IC is actually providing these values of the part. So, so 7.91. Similarly, we can do cat and so it will be a bit, that is even less. So these are not similarity based on how same they are. So there can be different relations and so. Yeah, so this is the way you have to do if any questions come in this. So I don't think they will ask you to code, but you can refer this library to know more about how to use this. And then there are different tests and so. Yeah, so this is I think the overall part, the bit of practical experience as well. So I will share the notebooks and video slides there. These are already the same location, and the notebooks will be added in the last slide, so you can check that. Any questions from your side?
No, sir.
Okay, so fine then. So this is the end of today's lecture.
Thank you, sir.
Thank you, sir.
Thank you so much.